All right, let's have a look at number 11. Ooh, this one looks spicy. Inverse cosine of 0. All right, what do I know about this? First of all, I know that my answer is going to be an angle, right? Because when we do an inverse cosine, the input is the ratio and the output is the angle. So I know my answer is going to be an angle, and I also know there's some restriction on the angle for my answer. I know that it has to be somewhere in the range from 0 to pi. If I'm thinking in degrees, that's 0 to 180. And I know that because that's where inverse cosine is defined. So we're only ever going to get an answer between 0 and pi. Okay, so can I figure this out without a reference triangle? So I'm thinking about this, and my issue is that I can't make a reference triangle with a side of 0. I can think about that as 0 over 1, but that would mean I need a side length of 0, and that just doesn't make sense. So what I need to do instead, I'm gonna recognize because of that, because I can't make a reference triangle, then we must be talking about one of our quadrantals. So the quadrantals are these locations on our unit circle, the ones that are in between the quadrants. So it's got to be one of those, and based on what I know, my answer has to fall between 0 and pi, so it's got to be one of these three. So then I need to figure out at which of these 3 points would the cosine of the angle be 0. Remember, this is what the cosine is equal to. So if we think about the x and y coordinates, at this point my x coordinate would be 0, my y coordinate would be 1. So the cosine of 0 is 1. That's not it. That's not our guy because we need this to be 0. So I'm thinking it's got to be this one, right? Because my x coordinate is 0 here. So it's got to be that point right there. What is my angle at that point? It's 90 degrees in radians, that'd be pi over 2. So the quadrantal ones are a little bit tricky. If you end up with a 0 or a 1 inside of an inverse trig function, that means you're going to be dealing on one of your quadrantals here. And you've just got to kind of think through what's going to make the most sense for, in terms of the sine, the cosine. Tangent gets a little trickier because it's not an x coordinate, it's not a y coordinate, it's a combination of the two. Are we feeling okay about number 11? Yeah, okay. Saul, which one did you? 27. Good. This one is a little beyond what you're going to see on the test. So if we can get ourselves confident with this, then we should be good to go. All right, so we're going to work inside out. So I'm just going to focus on this first. So I'm going to do the inverse sine of a half. What do I know about it? I know it's going to be an angle, because when you do an inverse sine, your output is an angle. And I know that it's going to be somewhere between negative pi over 2 and pi over 2. If I'm thinking in degrees, that's negative 90 to 90. This time around, I do have some sides that I can put onto a triangle. So I'm going to make myself a reference triangle. And I'm going to keep in mind that this ratio is positive. So I know that because my answer is from negative pi over 2 to pi over 2, I know I got to be in one of those two quadrants. And because my ratio is positive, that narrows it down to this one. This is the only quadrant where sine is positive that is in the range from negative pi over 2 to pi over 2. So it's got to be in this quadrant. So that's kind of the key piece of this problem. Are we feeling okay about identifying which quadrant we're in? Any questions there? All right, so my reference angle is right here. Sine is opposite over hypotenuse. That looks like a 30, 60, 90 triangle. I recognize that 1 and that 2. The other side would be root 3. And this is my 30-degree angle right there. So my angle is 30 degrees. In radians, that would be pi over 3. All right, so that takes care of that piece. Now we just got to work our way outside. So let me copy down the problem again. It's the cosine of 2 times the sine of a half. But now I know that the sine of a half is pi over 3. So multiplying that times 2, that's the cosine of 2 pi over 3. And I just need to work out what this is. On the test, a question, you might be asked to find the cosine of 2 pi over 3, or it could be in a problem similar to this. I would like to see reference triangles for this, even if you've already memorized. That would be... Pi over 6 is 30. You're right. I messed that up. Thank you. Woo. I was going to say pi over 3 is 60, and this is 122. Pi over 6, which is pi over 3. Yes. Thank you for that correction. Okay. That got all messed up. Stepping back to here, that's a 30-degree angle, which is pi over 6, not pi over 3. And then 2 times pi over 6 is pi over 3. Thank you, thank you, thank you. Okay. Are we good? Am I good? Do I have any other mistakes on there? I think we got it. When you do this on your test, I'm going to ask you to do a reference triangle. Has anybody started memorizing these, though? This will be our not the next memorization test, but the one after that. The next one is sine, cosine, and tangent for 0 to 90. So this is the cosine of 60. You all know pi over 3 is 60. Do we know the cosine of 60 yet? Do you know it? I'm putting you on the spot. What do you think? I think it's a half. I think it's a half. I'm pretty sure it's a half. But let's make sure. Let's make a reference triangle. It's a 60-degree angle. Thank you. Gotcha. That's awesome. That's a 60-degree angle. This would be my 1, my 2, my root 3, and its cosine. So yes, it is a half. And that'll be our final answer. Nice. Eventually, hopefully, all of you will have these memorized. What's the sine of 30? Anybody know the sine of 30? Sine of 30 is also a half. How about the sine of 60? Root 3 over 2. How about the cosine of 45? Spoiler alert, it's the same as the sine of 45. Root 2 over 2. It is 1 over root 2, but I'm going to want a rationalized version, so root 2 over 2. Sine of 90. Think about your x and y coordinates at 90. Y coordinate is 1. Cosine 90, 0. Sine of 0, 0. I think that's most of them. How about tangent of 30? This is the one I always have to think through. Tangent 30 is root 3 over 3, and then tangent of 60 is just root 3. So tangent, remember on the tangent, this is kind of how I wrap my head around it. Do you remember how your tangent graph kind of grows? Tangent starts at 0 and it grows up like this towards the asymptote. So as you go around the circle, tangent's going to get bigger. Tangent starts at 0 here and it's undefined here. That's where it hits that asymptote. And then it goes, and it's 1 right in the middle. And then there's two other ones. The other two are root 3 and root 3 over 3. And it gets bigger as it goes. So this is clearly smaller than this, right? So this has got to come first. This is my root 3 over 3, and this is root 3. There's lots of little tricks. All right. You don't need to worry about that for this week, though. What other questions do you have from your assignment? How about from the review? These problems on the review are very representative of what you'll see on the test, although there's stuff on the review that will not be on this test. That stuff is included here, though, because it may be on the exams. There are 2 word problems on the test. One is one is the last problem, and it's like a geometry level SOHCAHTOA problem about like a ladder leaning against a wall, or like somebody flying a kite. Like number 7, yeah. Tree casting a shadow, person casting a shadow. There's always one of those on the CWU exam also. Really simple, nice, straight ahead. Right triangle. The other one's going to be similar to Bob the Alien or the bullfrog problem. It'll be a sinusoidal, and I'll just tell you, it'll either be like a temperature rising and falling, or the depth of water, because the water depth changes because of tides. At high tide, the water's deeper. At low tides, the water's shallower. So it'll be something like that, where like, remember Bob got off the spaceship, and 2 hours later it was the first min, and 8 hours after that it was the first max. It'll be something similar to one of those. You'll be able to figure out what your equation is, graph it, and then answer a couple questions. How deep was the water at 5 o'clock? Or what 2 times during this day was the water 5.5 feet deep? Something like that. Yeah, and we'll go over some samples of that probably tomorrow or Wednesday. Other questions about the review before we get into another little practice test? Anything we need to go over here? I'm going to make this review due on Wednesday. I want this done by Wednesday. And the answer key is on, answers and solutions are on Canvas. I've got a paper copy over there as well if you want to take a picture after class is over. Get this done and my reason for that is I want you to be able to ask questions on Wednesday. So we're going to switch gears. I'd like you guys to get to a page in your notebook, and we're going to do some problems together. We got one extra day for review, but I'm claiming it. Well, I'm claiming half of the period today and half of the period on Wednesday. But with that time, we're going to do something that's hopefully very helpful to you. I have a copy of the test in front of me here, and I've gone through and just changed some numbers, or maybe changed a sine to a cosine, or a couple other little things like that. So I'm not giving you a practice test, but this is kind of a practice test. So I'm going to give you some problems. You're going to need to write them down in your notebook, and I'll give you some time to work on them. Ask questions. We'll go over solutions together and see if there's any gaps we need to fill in. So we'll do the first half of the test today and the second half on Wednesday. So let's begin. So this is going to be the first page. Number 1 is all going to be about unit conversion. So there's 3 parts to number 1. The first one, you're going to convert into radians. And this will roughly give you an idea of how the test is going to be formatted as well. All right. 105, excuse me, let me get caught up to you here. I'm going to multiply, that's degrees, so I need 180 degrees and pi radians. So whatever 105 divided by 180 is. And you guys know how to use math frac on your calculators, right? You're not trying to simplify these things in your head, are you? This is a test we're doing, right? So let's make sure we're utilizing our technology. 105 over 180 is 7/12. So 7 pi over 12, is that what y'all came up with? Woohoo! This one, 11 pi over 15, that's radians. So I want radians on the bottom, degrees on the top. Pi's cancel, so whatever 11 times 180 divided by 15 is, 132 degrees. And then the last one, you're just going to do 90, or 109 rather, plus 42 over 60 plus 18 over 3600. And you do not need to show me steps on the test for these three problems, but it might not be a bad idea, just in case you make a mistake. They're worth 2 points each, so if you did show me steps and your answer was wrong, I could give you some partial credit. Yes, sure. I just left a 0 out. I was talking and writing at the same time. Does that look better? Thank you. Keep checking me. I'm a little making lots of mistakes today. Okay. Are we all good on number 1? Any questions? So that'll be pretty straightforward. Might be a good one to actually start with. The instructions in number 2 say find an acute angle. And acute is underlined. And it does say to draw a reference triangle and simplify. So there are 2 of these. One of them looks something like this. There'll be a little bit of space underneath it, and then it'll say theta equals blank degrees and theta equals blank radians. So you're going to give me answers in both degrees and radians. Those of you who have memorized your degrees and radians are going to be super glad that you did, because it's going to save you a ton of time on this test. And even more time in the next unit. So the instructions will say that you're required to draw a reference triangle. Where's our reference triangle going to be? Based on the instructions, where must our reference triangle be? It's got to be in the first quadrant, right? An acute angle is between 0 and 90. So for both of these, your reference triangle will be in the first quadrant. The instructions say draw and label a reference triangle in the appropriate quadrant for full credit. So yes, I think XY axis would probably be a good idea. All right, I'll let you guys finish those up. Check a couple more people's assignments while you're doing it. All right, so sine is opposite over hypotenuse. So 1 radical 2, that's a 45-degree angle, which is pi over 4. On the test, last year I was accused of being a hypocrite because I demanded that people put their answers as rationalized numbers, but then I had some things on the test that were not rationalized. I can rationalize these if you guys want. I purposely didn't because it makes it easier to recognize the. So you guys okay with me doing that and understand that I'm not like it's not a double standard here. It's that I'm trying to help you. We're cool with okay. Thank you. All right. Tangent is opposite over adjacent, and this was here. So that's a 30, 60, 90 triangle. This would be my 60 because root 3 is bigger than 1. So 60 and pi over 3. Does that sound right? Any questions? All right. These next ones are this is number 3, and this. Whoa, that's not right. Oh, I did it backwards. That's why I asked you guys if it looked right. Oh, jeez. All right. Tangent is opposite over adjacent. Opposite is 1. Here's root 3. So, no, it's not 60. It's 30. So, pi over 6. I would not do well on this test today. Seriously. Okay, thank you. Thank you again. We got this. We got this. Okay. Next one. Number 3 is at the bottom of the first page. I'm going to give you 3 angles, and you just have to say which quadrant it's in. Here's 3 angles that are kind of similar to the types that you'll be seeing. No work is necessary here. In fact, on the actual test, it's going to have the 4 quadrants written out, and you just have to circle which one it is. But so you guys have been spending a lot of time with the unit circle. My hope is that you can visualize these, or maybe make a quick sketch and figure out where they are. Again, the last 2 are going to be much faster and easier for you if you've taken the time to memorize your degrees and radians. Not quite there. All right, that's the end of our first page. Any questions on that? All right, top of the second page, you're going to have number 4 will have 2 problems. It'll give you an angle, and then it'll give you a list of other angles, and you just have to circle which ones are coterminal to the one that's given. I ran out of room. Ooh. $16.65. There is a wonderful calculator trick you can use for this, so you don't have to keep typing plus 360 over and over and over again. Do you guys remember how that one works? Would you like a reminder? This will save you whole seconds of your life. Go into your calculator, type in 225, hit enter, and then type plus 360. And then it should say answer plus 360, and then you can just keep hitting enter over and over and over again, and it's just going to keep taking your answer and adding another 360 to it. And the ones that you see that match, circle them. And then once you got all your positive ones, do the same thing and do a minus 360 instead. There's going to be 2 of these. One of them will be in degrees and the other one will be in radians. So here's another one. 2 pi over 3. Which ones are coterminal with this? There's a shortcut for this as well. It involves math frac. When you do this in the calculator, you can do this in the calculator, just leave your pi's out. So normally you would add 2 pi to get to the next one. But just add 2. So if I were doing this using the little shortcut on my calculator, I would start by typing in 2 over 3, 2 pi over 3, but I'm leaving the pi out, hit enter, and then do plus 2. I'm really adding 2 pi, I'm just leaving the pi out, but math frac after it. Plus 2 math frac. So 2 pi over 3 plus 2 pi would be 8 pi over 3, 14 pi over 3, 20 pi over 3, and so on. So these should be pretty quick if you know how to use your calculator. I certainly would not want to be turning every single one of these into degrees. That would take forever. Just add 2 pi to each one of them. We good on number 4? Feeling confident about that one? All right, moving on. Number 5. This is the bulk of the second page. You're going to evaluate It does say simplified, rationalized, and reference triangle in the appropriate quadrant. So you will be drawing an X, Y axis and drawing a reference triangle for each of these. So I will give you some sample type problems and let you work through them, and then we'll compare answers here in a minute. Actually, I'm changing this last one. I don't like that one. Let's do any of you guys really happy that you just memorized your degrees to radians and radians to degrees? You're recognizing how much time that's saving you right now? I'm going to tell you that those who choose to memorize their sine, cosine, and tangents will have a similar experience on the Chapter 5 test. You don't have to. You can look it up. I'm going to give you a sheet that's got them all on there, but it'd be way faster to just know them. How'd I do? I nail it this time? Maybe. You know, like I said, we have a way to check these. So if you get done early, then please grab your calculator. You're literally, your calculator can do this if you're happy with a decimal answer. Make sure you're in the right mode. Cosine 225 and then negative square root 2 divided by 2. I'm confident in that one. I don't have a cosecant button, but I can do 1 over sine. 1 divided by the sine of pi over 3, and I did change my mode into radian mode, is that. I think my answer is 2 square root 3 over 3. So there's no need to wonder on these problems. You will be able to check. The next one's not so easy to check, but we've done a lot of these. I've thrown a lot of these into the assignments because, well, to be honest, these are the ones that are usually the most missed of the entire test. There's 2 of these. We'll just do one today. There's one at the bottom of the second page. There's one at the top of the third page. You're going to be finding, let's see, why don't we do sine theta and cotangent theta. If cosine theta is negative 3 over 7 and sine theta is greater than 0. So these problems involve a few different phases, the first of which is determining the quadrant. The problems will always provide you 2 clues about what quadrant you're in. One clue is going to come from this piece, and one clue is going to come from this piece. This first piece of information tells me that cosine of wherever this angle is, the cosine is negative. And wherever this angle is, the sine is positive. Greater than 0 is positive. So you will always be able to, from the given information, to be able to find positive or negative for 2 of your 3 main trig functions, sine, cosine, or tangent. And that will always be enough to pinpoint a specific quadrant. There is only one quadrant where cosine is negative and sine is positive. How many of you are using the all students take calculus thing? Anybody latch onto that? It's handy. It's a nice, quick way to know what stuff is in different quadrants. If you miss this, ASTC, if you draw this on your test, all students take calculus is how we all scholars take calculus. I don't know. It tells you which quadrant each of the things is positive in. So they're all positive in the first quadrant, only sine's positive in the second quadrant, only tangent's positive in the third, only cosine's positive in the fourth. So the fact that cosine's negative and sine's positive must mean we're in the second quadrant, because sine is the only positive one here. So that's your first phase, is figuring out where is my reference triangle. And then next you're going to put some numbers into it. You should be able to fill out 2 of the sides and then use Pythagorean theorem to find the third side. What is that, 49 minus 9? Let me get you some answers here, and then, oh, these ones too, plus and minus, right? Cotangent's negative in this quadrant, sinus positive in this quadrant. Sine is opposite over hypotenuse. Cotangent's adjacent over opposites. All right. I'll be around to answer questions. You guys got the rest of the period to work. We will go over some similar problems to, well, if I don't know, do you guys find this useful?